Apple's quest to revolutionize 5G technology hits a pivotal crossroads, signaling a potential shift in the tech giant's strategy. This revelation comes amidst reports that Apple might cease its endeavors in developing its own 5G baseband chip, choosing instead to adopt Qualcomm's chips while compensating for patent fees. Could this decision mark the end of Apple's ambition to dominate the 5G landscape, or is it merely a strategic pivot in the face of overwhelming challenges? Dive deeper into this fascinating turn of events and discover what it means for the future of mobile technology. Stay with us as we unravel the layers behind Apple's strategic maneuvers and the implications for the tech industry at large. Recent reports from various media outlets suggest that Apple may halt its research and development efforts on its 5G baseband chip project and opt to utilize Qualcomm's baseband chips instead, while also compensating Qualcomm for patent fees. Speculation in the market indicates that Apple's decision to discontinue its R&D endeavors stems from its inability to produce a 5G baseband chip that aligns with its stringent requirements. Despite previously utilizing baseband chips from Infineon and Intel, Apple has shown reluctance to rely on Qualcomm's offerings due to dissatisfaction with the company and concerns regarding market share. However, the advent of the 5G era has compelled Apple to negotiate a settlement with Qualcomm, resulting in the continued use of Qualcomm's baseband chips and the payment of patent fees. Concurrently, in an effort to decrease its reliance on Qualcomm, Apple invested $1 billion USD in acquiring Intel's baseband chip business and initiated its own development of baseband chips. Despite these efforts, 4 years later, Apple's proprietary 5G baseband chip remains unreleased and faces the prospect of being discontinued. Examining the challenges Apple faces in developing baseband chips, it's essential to consider the technical complexities involved. The baseband chip serves as the communication module in mobile phones, facilitating communication between the device and the mobile communication network's base station. It is responsible for tasks such as modulating, demodulating, coding, and decoding uplink and downlink wireless signals. Beyond supporting 5G networks, a 5G baseband chip must also be compatible with various other networks, including 2G, 3G, and 4G. Accommodating the diverse requirements of these networks necessitates extensive accumulation of patents, technology, and experience over time. Apple's proficiency in communication technology is relatively lacking, almost as if starting from square one. Furthermore, while Apple's internally developed chip technology excels in various domains, its expertise and track record in communication technology are notably deficient. Should Apple aspire to craft a baseband chip on par with Qualcomm's, it must commit significant resources in terms of manpower, materials, and finances. However, despite substantial investment, progress has been lacking, prompting Apple to reassess its capabilities and resources to determine if it can genuinely produce 5G baseband chips that satisfy market demands. The significance and intricacy of baseband chips, fundamental components of mobile phones, cannot be overstated. Not only do these chips profoundly influence communication quality and speed, but they also impact mobile phone power consumption and stability. In the 5G era, their importance is further heightened. Besides facilitating high-speed and reliable data transmission and communication, they must also adhere to elevated standards of security and reliability. Consequently, for a company like Apple that prioritizes technological leadership and product excellence, developing an independent 5G baseband chip that meets its exacting specifications poses a formidable challenge. Additionally, alongside the technical hurdles, the patent landscape surrounding baseband chips is of paramount importance. Diverse communication standards and formats necessitate the utilization of corresponding patented technologies, underscoring the need for ample patent authorization and technological accumulation. Throughout the development process of baseband chips, ensuring product compliance and stability hinges on navigating these patent requirements. Consequently, Apple may perceive the investment and risks associated with developing its own baseband chips as disproportionately burdensome compared to seasoned industry players like Qualcomm. The prospect of collaboration between Apple and Huawei has been suggested as a potential solution to Apple's predicament regarding self-developed baseband chips. Some internet users have proposed that Apple could explore partnering with Huawei, Given Huawei's esteemed reputation as a leading provider of communication equipment, Huawei's baseband chips enjoy widespread recognition in the international market for their performance and reliability. Integrating Huawei's baseband chips into Apple's products could not only reduce Apple's reliance on Qualcomm, but also offer access to cutting-edge communication technology. While such a collaboration seems promising, its feasibility hinges on various commercial factors and the willingness of both parties to engage in cooperation. However, the current political landscape introduces significant uncertainty to potential collaboration between Apple and Huawei. The U.S. government's imposition of technical restrictions and sanctions on Huawei complicates matters and casts doubt on the viability of cooperation with Apple. Moreover, competition between Apple and Huawei in terms of intellectual property rights and market share further adds complexity to the situation. Consequently, despite the potential for collaboration, there are no clear indications that Apple and Huawei will indeed partner. Despite opting to discontinue the self-development of 5G baseband chips, Apple's decision does not signify a retreat from its commitment to technological innovation and independent research and development. Instead, it reflects a pragmatic response to the realities of the market, given the immense complexity involved in developing baseband chips, which surpasses China's initial expectations. Apple remains dedicated to pursuing independent research and development efforts. Although Apple has yet to produce a 5G baseband chip meeting its standards, there is confidence that it will persist in its endeavors to achieve this goal in future developments. Ultimately, for consumers, whether they utilize Qualcomm or Huawei baseband chips, the primary objective is to enhance communication quality and user experience. This overarching goal underscores the importance of technological advancements and innovation in the realm of baseband chips. In summary, Apple's consideration to halt its 5G baseband chip development and lean on Qualcomm's technology underscores a strategic recalibration rather than a retreat from innovation. This move, reflecting the daunting technical, legal, and competitive challenges in the baseband chip landscape, highlights Apple's pragmatic approach to sustaining its technological advancement and market competitiveness. As the company continues to navigate the intricate dynamics of the mobile tech industry, its decisions will remain critical in shaping the future of 5G connectivity and mobile communication, ensuring that user experience and product excellence stay at the forefront of its priorities. What do you think about Apple's potential shift to Qualcomm's 5G chips? Do you believe this strategy will strengthen Apple's position in the mobile technology market, or does it signal a setback in their innovation journey? Feel free to share your thoughts and perspectives in the comments section below. Don't forget to become a part of the RlD Discovery community by hitting that subscribe button to stay informed about the latest technological advancements and innovations. Remember, as we delve into the realm of technology, the possibilities are limitless, and the future is filled with exciting discoveries. Keep exploring.